When you wake up and want a coffee, you don't think about thermodynamics. You just press a button and the machine does the rest. You don't have to calculate the exact water temperature, measure the electrical voltage, or calibrate the grinder gears. All of that messy, mechanical reality is happening inside the machine, completely hidden from your view. The exact same thing happens when you tap the screen of your smartphone to take a photo. You aren't manually calculating focal lengths or adjusting light sensors. You just tap. This deliberate hiding of complex details behind a simple interface is called abstraction. And in the digital world, it is the foundational trick that programmers use to build complex software without collapsing under the weight of a million moving parts. To see how this works in code, imagine you have a massive, unorganized list of numbers that needs to be sorted. This diagram shows how a programmer solves sorting. Instead of writing complex mathematics every time, they pack the logic into a reusable digital box called a function. It handles requests independently, taking unorganized data and spitting out the sorted list. Functions act exactly like digital magic buttons. Any developer on the team can now sort a list of data just by knowing the name of the function to call. They never have to understand how the mathematical sorting actually works. If a function is a single button, then a class is the entire machine. Think of a class as a self-contained digital object, like the camera software on your phone. Inside that camera class, there is a massive amount of hidden complexity. There are separate pieces of code working together to focus the lenses, adjust the exposure, and capture millions of pixels in a fraction of a second. But by bundling all of those complex actions into a single class, the programmer can expose just one simple public command to the outside world, like a command to simply take a selfie. The rest of the program only ever interacts with that one command. Now, let's say you want to take that selfie and save it to a massive cloud server owned by a completely different company. To do that, you use an application programming interface, or API. It acts as a structured barrier, allowing your code to securely talk to external servers. It's an agreement. Send a file in a specific way, and I'll store it. APIs represent the ultimate layer of abstraction. They let developers tap into billion-dollar global infrastructures just by sending a simple text command, completely shielded from the physical reality of the server farms doing the heavy lifting. So why do programmers spend so much time rigidly building these abstraction layers? First, it allows for a massive division of labor. One developer can spend their time perfecting the complex math of the camera logic, while another builds the user interface. Because the inner workings are hidden behind simple commands, their code doesn't crash into each other. Second, abstraction allows for invisible upgrades. If a company figures out a faster, more energy-efficient way to process photos, they can completely gut and replace the underlying code. As long as the external command, that take a selfie button, stays exactly the same, the person using the app doesn't have to learn a new way to interact with it. The engine changes, but the dashboard remains untouched. In theory, this system operates perfectly, but in practice, the physical world occasionally shatters the digital illusion. Your Wi-Fi connection drops in the middle of a cloud save, an external API server gets overloaded and crashes, or the physical hard drive on a database fails. This is known as the law of leaky abstractions. Coined by software developer Joel Spolsky, this law states that no abstraction can perfectly hide all the underlying physical or logical complexity forever. Eventually, something leaks through. When a leak happens, the magic button stops working. The programmer is suddenly forced to look under the hood, learn how the hardware actually operates, and deal with the messy reality they hid. Leaks are inevitable, but the vast majority of the time, abstraction successfully holds our digital world together. It tames the chaos of modern computing, allowing us to simply press a button, enjoy the result, and let the hidden code do the rest.